Hi, everyone. Welcome to IS 351 or Science Inquiry 1 on Monday nights. I'm really sorry that I can't make our very first face to face meeting. So I'm hoping that this video lecture won't bore you to death too much and make you not want to come back. I find that I'm not as animated as I usually am in class when I'm having to do a video lecture, but maybe since you can see me a little bit, we can get this going on the right path from the very beginning. I'm going to present this just to make things a little bit better, which means that you're going to lose me because it's going to present right over the webcam at the bottom of the screen. So we're going to try to make this as painless as possible. I'm going to show you around the D2L, Brightspace, whatever they're calling it now, website or portal or whatever you want to call it. And tell you a little bit about the class. I do have a 15-minute window limit on this for the screen recording, so hopefully we can get it all done in less than 15 minutes. So here we go. And it's starting. Love it when technology works. Here we go. So I like comics. I like jokes. I like physics. All of it together. And I'm doing this from the hotel room. So if you hear any weird noises, that's why. So 351 is going to be our physics-based class, and it's going to be all about looking at physics through really learning physics. I'm here to teach you some physics, but we're also going to be switching back and forth between student hats and teacher hats for a little while, just to make sure that not only are you learning physics, but you're learning some best practices when it comes to teaching physics. I am all about relationship building, and since I'm not able to be there on our first day, these are just some pictures of me. And normally, what I do is I throw these up on the screen, and I get you guys to ask me questions. This is kind of a one-way communication, so here's what you're going to have to do. You're going to have to take a look at these lovely images of me and my wife and my son, which they're a little old now, and some other things that I have there. And I want you to think about some questions that you might want to know or want to ask me about anything that you want to know about me. The one thing I say is that social security number and mother's maiden name are off the table, but pretty much everything else is fair game. So I expect that you're going to come to class next time, I guess really in a couple weeks since we have the MLK Day, with some questions for me. And I want them to be good questions. Don't ask, like where I went to college, because you can Google that, and you can literally Google that. I'm on like the first 5 pages of Google. All right, about Isaac Newton's, more like Isaac Newtons. See, it's funny. All right, that doesn't really work as well when it's a one-way interaction. Cool. Okay, so before we get into this, actually, let's get a couple slides in, and then we can switch out of that. So this class is all about just taking a look at what science is and the nature of science. I did adapt this from one of my college professors when I was in my graduate degree program at the University of Texas at Dallas. So I'm giving her credit right there, Dr. Mary Urquhart, which is great. So if you ever have any opportunity to go to UT Dallas, you should look her up. She's great in the math and science education department. Anyway, so what is science? So what you would normally do in the physical class, and if everyone was there, is that you would think to yourself what your definition of science is and work with the people around you to come up with a definition of science. So the way that we are going to do this here is we're going to jump over to the D2L Brightspace portal. I had this set up as it was looking at a student, so hopefully this is going to be the way that it looks for you. And we can go into content up here, or you click on the week one right there. I'm going to click on content because I like the way it looks better when you do it this way. That's just my personal opinion. Come on, here we go. And you can see some of the things that I have posted, such as some information about me, the syllabus, which you should definitely take a look at, and we can talk about a little bit later, some notebook information, which we'll talk about a little bit later, and then the week one assignments. So you have the notes that I'm going through right now. You have your own copy right there, reading that we'll talk about in just a second, and then a couple of week one assignments, one of which is a discussion topic where you're going to go in there and post your definition of the word science. So think to yourself and come up with a definition of science. There's some instructions there about what you would do after your initial post. You're going to respond to 2 other posts, so you have to make 3 posts total. One on your definition, and then you find someone you agree with and find someone you disagree with and have a quick discussion with that. So I hope that these posts are really, really great and really informative and get at some really good ideas about science. So that's one of your assignments before I see you again, which is not until January 28th because of the MLK holiday. So Pause the video and go do that. I'll wait. Okay, I'm done waiting. I'm going to come back. Let's get back to presenting. So what about a physical law? So this is not a 1, 2, 3, 4. A physical law is all of these. These are just possibilities, more like a multiple choice. I really should change that to A, B, C, D. 1, a physical law is an absolute truth. Nature always obeys physical laws. 2, a reasonable guess based on observations. 3, more of a rule than a law. It's true most of the time, but there are always exceptions. Or 4, well-tested descriptions of how nature behaves. So pause the video. Think about it. Okay, are you back? Great. So let's move on. Don't worry, I will tell you in just a second. A law, hypothesis, a theory. What do these terms mean to you? And in the context of science, these terms, a lot of people use them interchangeably. Law, hypothesis, theory, they are not the same thing. It does not cease to irritate me whenever someone says it's just a theory, whenever we're talking about something in science. But that is an argument for a whole other day because I could probably go on and on about that. So pause the video. Think about what it means to be a law, a hypothesis, a theory in science. What does it mean? Okay, great thinking. Cool. So this is actual definitions from the National Academy of Sciences, more of a textbook definition, more of if you were to look it up in a dictionary. So a fact is in science and observation that has been repeatedly confirmed. So a fact would be something like, if I drop something, it falls. Yeah, cool. That's a fact. It's been repeatedly confirmed. A law is a descriptive generalization about how some aspect of the natural world behaves under stated circumstances. So I'm going to back this out real quick so you can see me. A law. There's a lot there. A descriptive generalization about how some aspects of the natural world behave under stated circumstances. So one of the big examples that I like to give here is the law of gravity. It's the law of gravity. We know about gravity, right? Gravity holds things to planet Earth. It's a force that pulls things down to the center of the Earth. So a law is, hey, if I drop this anywhere on planet Earth, if I'm standing even on the second floor of this hotel that I'm at, I'm actually on the 11th floor. If I drop this, if I let go, it will fall. Hey, look, it fell. So the law of gravity says that if I allow something to fall, it will. Gravity pulls things down to the center of the planet. That is the law of gravity. The specific statement is that anywhere on Earth, now, if I was out in the middle of space, it wouldn't work. But only here on Earth, does this work. Actually, we can go a little bit broader and say if you're on the surface of any planet, as long as it has a hard surface, obviously, that is the law of gravity. Now, here's the thing, is that because it is under stated circumstances, laws do not have exceptions. I'm going to say that again. Laws do not have exceptions. They work every single time. The way I test whether something is a law or not is it has to pass the holy crap test. So here's the holy crap test. You ready? So here's my apple, right? Put it over here. If I were to let go and it would just hang here, what would you say? You'd probably say, holy crap. It's supposed to fall, right? So if it doesn't do what it's supposed to do, then that would mean that it defied the law. But if it has something that it is supposed to do every single time, then that is a law of nature. Okay, moving on. So a hypothesis, a testable statement about the natural world that can be used to build more complex inferences and explanations. Emphasis on testable, right? You're making a statement and you're going to test it using the methods of science. And then theory. In science, a well-substantiated explanation of some aspect of the natural world that can incorporate facts, laws, inferences, and tested hypotheses. So I can go on and show this. I'm going to blow this up. I'm going to present this. This is, in my opinion, a great way of looking at how a theory is built. First off, we start with observations. In science, we make observations, we look, we use our senses, we use technology, we use tools, we use measurement devices, we make observations. From those, we can develop scientific laws. What are some things that we notice happen every single time, or what is something that nature always does? We can make hypotheses about these laws and what would happen if we change something. We can do experiments and get results from that. We can come up and just incorporate it with other facts that we know. And all of that stuff holds up a scientific theory. Take a guess. What is the most experimentally proven scientific theory in all of science? Go ahead, take a guess. Go ahead, take a guess. I can't hear you. So the theory is evolution, right? The most scientifically proven and verified and backed up theory in all of science is the theory of evolution. And it just irritates me to no end when someone says, oh, well, that's just a theory, because they're implying that it hasn't been proven. When in fact, there is so much evidence and so much background to say that it is the current best explanation for how things work. Means that there was centuries of work prior to what we know now that led us to this point, and that is our best explanation of the natural world. So we have the scientific revolution. So here's a question for you: how long has the scientific method been around? Now you guys know the scientific method. I'll show you at the very end. But the scientific method, you come up with a hypothesis, you test it, you take some data, you review it. Did the experiment prove the hypothesis? Yada yada yada. You guys know that. How long has it been around? Would it surprise you to know that it's been only been around since about the 1930s? And that it's kind of coming from well, yeah, we've been doing science way before 1930s, right? I mean, Isaac Newton was back in the 1700s. We know that things were done prior to the 1930s in science. So here's the thing about science, and that is that it was all about the motivation behind how you do science. And in the 1930s, that kind of changed with this guy named Karl Popper. So I'm going to go back over to the D2L website, because one of the things that I skipped over was this guy right here, the Karl Popper reading. So I want you to read that. It's only about a page, and it's really not even that. I'm really interested in the seven points that he makes on that one page, and I want you to be prepared to discuss this when we get to class the next time. We're not going to spend a whole lot of time on it, but I want you to take a look at it. So Karl Popper, and I'll tell you, one of the more fascinating things is his ideas about this guy right here, the idea of falsification. So I want you to think about that. There's a scientific method. You have it in the notes. I'm not going to go over it. You guys know this. I'm sure you've done science at some point. Cool. Experiment. We're actually going to define all of these terms in context as we go through this course, but these are some things that we should know about by the end of the course. Here we go. So the homework after watching this video. So you're going to go to the D2L Brightspace, and you are going to take a look at all of the course information. So the syllabus, the project information, and by the project, I mean the notebook. So I'm going to go ahead and open this up right here. So the notebook instructions right here, basically, and this is in general form. I'm going to make a couple statements. Basically, you're going to create a live binder, which is a digital notebook. And everyone who has been through at least one of my courses probably is thinking, heck yeah, we're doing it digitally this time instead of a physical binder. So it's a digital notebook where you are going to be using the TEKS, and you're going to be finding experiments that go with the TEKS. But this one is specifically looking at a vertical alignment between three different grade levels. So it's your job to choose three different consecutive grade levels that you possibly might teach in the future, what you're thinking. So 3, 4, 5, 4, 5, 6, 1, 2, 3. I'm going to say that with this project, the lower the grade level, the harder it's going to be. So if you're thinking K1, 2, it's not impossible, but it's going to be very difficult. But what you're going to do is you're going to look at the TEKS, the standards in science for the state of Texas, and you will vertically align them. Basically, you're going to, and we'll do this in class 1, so you can kind of see this, a TEK that is in a third grade, then something similar in fourth grade, something similar in fifth grade, that align through those three grade levels. And you're going to find experiments that could apply to that TEK, and you're going to find a total of, I believe it's 30, but take a look at the instructions. There is some information about an info sheet and spreadsheets that are listed in the instructions. And then there's an example here. So you can click on this link and go to an example live binder that I have set up to help you out with that. I suggest starting on this early, because you're going to be finding a lot of experiments and you have a lot of work to do some alignments to it. So here's some things to kind of help you with that. So yeah. So get started early. It is kind of a beast. Don't let it go to the end. And I'm more than happy to take a look at anything that you want me to before you turn it in. And we'll turn in at the next time I see you. All right, where am I? Content. Okay, so other assignments for you to do. So we already talked about the discussion question. So the what is science discussion question. There's information there about what to do on that. But since I'm not really going to get to see you for a couple of weeks, I have another thing to ask of you. And that is, where am I? In the week one assignments, is to introduce yourself to me. And one of the things that we're going to use a couple times this year is going to be Flipgrid. And you can do this on a phone, or you can do this on a computer. But basically, you're going to be recording a video, 90 seconds or less, that tells me who you are, why you want to become a teacher, and you're going to post it to the Flipgrid topic, which has this code that goes along with it. And there's a tutorial about how to use Flipgrid